Alright, so the instructions say to find the zeros or the roots and then to write the function in factored form. So the first thing we do is check to see if it has any GCF other than 1, and this one does not have that. So then from there we go straight to finding the P factors and the Q factors. The problems today all have Q factors of plus or minus 1, okay, because I didn't want to include the other type just yet. So this would be plus or minus 1, plus or minus 2, and these are factors of 8, okay? For Q, like I said, I chose problems that have a leading coefficient of 1 for the 4 homework problems tonight. So that way we know that for these 4 problems, P over Q is going to be the same list as P, okay? Because when you take 1 over 1, you get 1. When you take 2 over 1, you get 2. When you take 4 over 1, you get 4. When you take 8 over 1, you get 8. Okay? So the P over Q ratio is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So now out of all the numbers, all the rational numbers on the number line, these are the only 8 numbers that can possibly be zeros for this polynomial. No other rational numbers can be zeros for this polynomial. So we start with 1 and just do synthetic division. Okay, so there it is set up. So you bring down the 1. 1 times 1 is 1. Then you get 0. 0 times 1, 0. Then you get negative 10. And then you get negative 10 here. So this one does not work. So we try 2. Okay, so it's all set up with 2. So bring down the 1. 2 times 1 is 2. Then you get 1, 2, negative 8, negative 16. So this one doesn't work. So you bring down, we try 4 now. And I'm just going down this list right here. Okay, I'm just going down. I started with 1, then 2, now I'm on 4. So bring down the 1. 1 times 4 is 4. 4 minus 1 is 3. 3 times 4 is 12. 12 minus 10 is 2. 2 times 4 is 8. So now this one, since we got remainder 0, we know that 4 will work. Okay? That 4 gave us a 0. 4 is a 0 of the polynomial. Now what you guys have to remember is what these 3 numbers mean. Remember, this is x to the 0, x to the first, and x squared. So this is a polynomial x squared plus 3x plus 2. Okay? And then the 4 up here, this 4 right here that gave us a 0, means that this is x minus 4. So now we have to factor, once you have a quadratic, okay, once you have 3 numbers here and the 0, then you can stop using synthetic division and just convert it to the quadratic like this and factor it, or quadratic formula, either one. And so factors of 2 that add up to 3 are 2 and 1. So I can factor, I'm going to write it up here, I can factor f of x as x plus 2 times x plus 1, and then just don't forget to copy the x minus 4. So these 2 factors here are the ones we get from x squared plus 3x plus 2. Okay? So the zeros are negative 2, negative 1, and 4. So these are the zeros of the polynomial. If you have to sketch it, again, this was not part of your homework, but it's good to put all the pieces together because eventually you guys are going to have to do this. So it's just good to kind of keep reviewing this. So you know that the end behavior is down up because it's a positive leading coefficient with an odd power, an odd degree. So it's down up. You know that the graph is going to cross through all the zeros because their multiplicity of each one is 1, because here's 1, here's 1, and here's 1. So the multiplicity of each of these is 1. So down up, it's going to go through negative 2, then negative 1, then 4. Okay, and this number right here we know is negative 8, because that's when you replace all the x's with 0 in the polynomial up here, you're only left with -8. So this number is -8, the y-intercept. Okay? Alright, so the factors, the p factors are quite a few because of 60, right? So let me just write. So p factors are plus or minus 1, 2, 3, 4, 5, 6, 10, 12. So these are all numbers that are factors of 60. 15, 20, 30, and 60. All of these are factors of 60, right? And those are the other ones. The nice thing about this list, this P list is so long. The only good thing is that the Q list is short. It only has, oops, I don't know why I put a -1, plus or minus 1. So when we do P over Q, it's basically just the list of P numbers because we're going to put all these numbers over 1. So plus minus 1, plus minus 2, and I'll just put etc. because it's basically this list right here. So we don't have to rewrite it all over again. Okay? So now we're going to factor. We're going to divide with synthetic division. So I'll start with 1. 1, 2, negative 23, and negative 60. Bring down the 1, 1, oops, 3, 3, negative 20, negative 20. So that's negative 80. That's not going to work, right? And then you do the same thing with 2. Whoops, that's a 3. And 1, 2, 4, 8, negative 15, negative 30. It's even getting more negative, right? So you try 3. And 1, 3, 5, whoops, 15, negative 8, negative 24. Okay, so that's less negative, so it's getting closer to the x-axis. Okay, so negative 84. We try 4. 1, 4, 6, 24. 1, 4, negative 56. Okay, so notice how the values are getting closer to the x-axis. So we started off kind of further away. Now this is closer, so this is closer. So hopefully the next number will work because we're trying to get to 0. So 1, 2, negative 23, negative 60. Bring down the 1. 5, 7, 35, 12, 60, and we got it. It works. So this one works. Okay. Now, what do you have left? This is a quadratic. How do I know that? Because I've got 3 numbers left, not counting the remainder, right? So this means this is x squared plus 7x plus 12. The 5 means that the factor that works is, or that gives me a 0, is x minus 5. So factors of 12 that add up to 7 are 3 and 4. Because this is a 1, I don't have to do the x factor or the little box. All I need to know is these factors, 3, 4, so I know that it's x plus 3, x plus 4, and don't forget the x minus 5. So this is the factored form of f of x. So the zeros are negative 3, negative 4, and 5. And again, if you had to sketch it, so these are the zeros, and this is the factored form, so those are the answers they're asking for. This is another down-up polynomial. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The zeros are negative 3, negative 4, and positive 5. The graph crosses through each of those zeros, and it's a down-up. So it's going to go like this, like this, like this. Whoops, I should have crossed on the 5. And then this number, I know it's not to scale, but this number would be negative 60. And that would be the graph. Alright, so number 9, it's a 4th degree polynomial. I've already listed the p's and the q's. And again, because q is plus or minus 1, the list of p over q is basically the list of p numbers. Okay, because all of these numbers are going to go over 1. Okay, again, that's just, I chose those on purpose. That I gave you all leading coefficients equal to 1 for today's homework. So we start off with 1, 5, negative 1, negative 17, and 12. Bring down the 1, 6, 5, negative 12, and 0. So that one works. Now, because 1 worked and I don't have a quadratic, actually what I have here with these 4 numbers, I have a cubic, right? This is x cubed. So I can't use factoring or quadratic formula. It doesn't work for this. So I've got to keep using synthetic division. Now, since 1 worked on the original, I'm going to try 1 again on the reduced polynomial, which is this one right here. I'm no longer going to use the original numbers. I'm going to use these now, okay, for the rest of the problem. As I break it down, or factor it, I should say, I use the reduced polynomial. So 1, 6, 7, 7 times 1, 7, 12, and that one worked. Okay, again, it worked on the polynomial. So now I have a quadratic. This 1, 7, 12 is a quadratic. It's x squared plus 7x plus 12. And again, I think that was the same as the other problem, right? The quadratic we had as a factor. So factors of 12 are 3 and 4, and they add up to 7. So my factors are x minus 1. It worked twice, so it's squared. And then x plus 3 and x plus 4. That's my f of x. I ran out of room on the left side, so that's why I put f of x on the right side. The zeros are 1, negative 3, and negative 4. And if you had to graph it, the multiplicity of 1 is even, and this is an up, so it would go negative 3, negative 4, and here it's going to be tangent, so it's going to cross, and tangent. So number 10 has a great common factor. It's x, right? So we're going to take that out first, and you end up with this. And the p-values in this problem are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The q values are plus or minus 1. So p over q is your same list as p list again. So now I'm going to do synthetic division. Again, I am doing synthetic division on the cubic function, okay? Because remember, we factored out the x. So it's going to be 1, negative 6, 11, negative 6. Bring down the 1, negative 5, 6, and 6 and 0. So it worked. And then this one here is a quadratic, which is x minus 2 times x minus 3, right? So my polynomial is going to be f of x equals x, don't forget the x that we factored out at the beginning, x minus 1 from right here, and then x minus 2 times x minus 3 from the quadratic at the end. So the zeros are 0, 1, 2, and 3. So the multiplicity of each 0 is odd because the power of each factor is 1. And so if you had to graph this, and this is another up, 0, 1, 2, 3, like that, the zeros would be here, 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 and here. It's an up, so it would just go through, and that would be a very simple sketch, but that's number 10.